All right, hopefully you found the correct lesson. This is Algebra 2, Lesson 2.1, Relations and Functions. All right, so Lesson 2.1, hopefully you got your notes with you. And take good notes. Remember, pause, rewind as you need to. All right, this is 2.1. Most of this should be reviewed from Algebra 1, but then again, it's been a couple years, and so let's go ahead and review. All right, so we've got relations and functions, and we start off in a Cartesian plane. Cartesian plane can also be called a coordinate plane. A coordinate plane. And as you remember, you've got a horizontal axis, and that horizontal axis is the x-axis. And then you've got a vertical axis, and that's the y-axis, right? So horizontal axis is the x-axis, the vertical axis is the y-axis, and they intersect at a point we call the origin, right? At the origin, and I spelled that wrong. All right, so they intersect at the origin. What are the coordinates of the origin? And it is 0, 0, right? Also, remember that the axes break up the plane into 4 quadrants, and so you should always be aware of quadrant 1 is. Remember, you use Roman numerals in depicting your quadrants. So quad 1 is top right, quad 2 is top left, quad 3 is bottom left, and quad 4 is bottom right. All right, so you got 4 quadrants in the Cartesian plane or the coordinate plane. All right, a relation. A relation is simply a set of pairs. A set of pairs. So a relation is a set of pairs. So if you go back up to the Cartesian plane, you can see that all of our points, the location can be found by the set of coordinates. So for example, point K here has coordinates of what? -4, 2, right? Point P over here has coordinates of 2, -4. Always the x coordinate, of course, and then the y coordinate. Point L right there would have coordinates of what? And hopefully -2, 0. All right, let me get back now to our relation. What is a relation? It's a set of pairs. And so we see a couple of examples here. And let me focus your attention right here. You know, we're looking at the first set, set B. And what are the pairs? Well, you got the point 1, 3. You've got the point 4, -1. And you've got the point 7, 5. All right, everything is paired up. And so a relation is simply a set of pairs. Second example, example K, we have 4 points. -1 is paired up with 0, 2 with 4, 3 with 4, and 5 with 7. Okay, so sets of pairs. Now, if everything were not paired up, then you would not consider it a relation. It would not be a relation. Everything has to be paired for it to be a relation. C says all the first elements of the relation form a set called the, do you remember? What do you call all the X elements? And it is the domain. The domain. All the first elements. And each first element, by the way, is called an abscissa. And all the abscissas form a set called the domain. All right, so D of B, what's the domain? I'm looking right here, the domain of set B. That's what that means. And you're simply going to put in the values of each X coordinate. So you got 1, you got 4, you got 7. Close it off with a brace. All right, in our second example, what is the domain of set K? And you've got -1 and 2 and 3 and 5. And close it off with a brace. Always list your members in braces. That's just proper set notation. And you guys did that in geometry as well. All the second elements called an ordinate, right? Get rid of the co for coordinate and leave ordinate. All the ordinates, we can also call them the images. All the images form a set called the, and hopefully you're thinking range. Now, domain and range are key words, and you've got to know what they are. I mean, you have to know that all the X's are the domain and all the Y's are the range. You have to know that, all right? So put an asterisk there and make sure that um, that you have those terms down. You got to know domain. You got to know range. All right, so again, same situation. Look here under D, and what is the range for set B? And now you're just simply going to list the Y values. It's best to list them in order from least to greatest. It just makes life easier, right? I mean, what's in the set, -1, 3, and 5? I mean, they're all there. Doesn't matter in what order, but for ease sake of understanding everything there and for checking, we just do them least to greatest. Not a big deal. All right, what's the range of set K? So again, we're looking up there. You got 0. You have 4. You have 4 again, but you would not list 4 twice, right? It's 4 is 4. So it only gets listed once. You would be incorrect if you list it more than once. You don't want to do that. All right, so the range is 0, 4, 7. Then relations and functions can be illustrated using a mapping diagram. A mapping diagram. A mapping diagram is simply a picture of the set. Usually it's circles, it could be rectangles, could be triangles, really could be any kind of shape. The left is the domain, and it's always good to label, and the right is the range. So we're going to come back up here to set K, and first off I'm going to list all of my domain. So I have -1, I've got 2, I've got 3, and I've got 5. I'm going to come over and list my range, 0, 4, 7. Again, do not list 4 more than once. Right, 4 is 4. The last thing you have to do is the actual mapping. The mapping is drawing an arrow from the abscissa, the member of the domain, to the ordinate, its ordinate, the member of the range. So -1 is paired with 0. Please include the arrowhead. That's supposed to be there. 2 is paired with 4. 3 is also paired with 4. And then 5 is paired with 7. All right, a mapping diagram. And it shows you the relationships between the domain and the range. That's its purpose. Okay, let's continue on. All right, let's get to a function. So a function, what is a function? A function is a special relation. So all functions are relations. Is every relation a function? No. All right, you have to meet another set of criteria. So all functions are relations, meaning all functions are sets of pairs. However, there's one more stipulation. So again, let me say that again. Are all functions relations? Yes. Are all relations functions? No. A function is a special type of relation, meaning a special condition, right? So it's a set of pairs where no ordered pairs have the same x-coordinate. Where no ordered pairs have the same x-coordinate. Now, you know me, if you remember back from Algebra 1, I like to call the guys x's and the girls y's. And it's then really simple. If the x's are guys and the y's are girls, then no guy can date more than one girl. No guy can date more than one girl. And if you remember the explanation of that, it's quite logical. If any guy dates more than one girl, they'll be found out because girls always talk about their dating and guys and stuff like that. And surely it will be found out and you'll be busted and you'll be dating no one. So any guy cannot date more than one girl. Now, by the way, can any girl date more than one guy? And the answer is yes, because that's not a problem because guys are talking about sports or, this video game or something like that. And they can get away with it. All right. That's just the reality there of life. But in math, any x can be paired up with only one y. And if that's the case, then you have a function. So Focus your attention here. Let's look at the first example, set B. It's a relation because it's pairs. 1 is dating 3, should be a comma there. 2 is dating -1, and 3 is dating 5. Okay, good. That one fits criteria. That is a function. Look at our second situation. All are pairs. Okay, good. -1 is dating 0. Fine. 2 is dating 4. Not a problem. 3 is also dating 4, but that's not a problem. 3 is not dating 2 girls. 2 is not dating 2 girls. Girl 4 happens to be dating both guy 2 and guy 3, but again, for it to be a function, that's not a problem. Now, let me pause right here and say what's going on. And so again, let me give you the big picture here on functions. You talk about functions, you talk about inputs and outputs. The x values are the input and the y values are the output. Think of like a keyboard and you're inputting data into a computer. So here's what happens. When you input a -1, it knows to output a 0. If you input a 2, it knows to output a 4. If you input a 3, it knows to output a 4. If you input a 5, it knows to output a 7. So there's a definite output for any given input. That's a function. That's a function. Now, if that were not the case, it wouldn't work, and I'll show you that here in just a little bit. Okay? Third one, again, we got a whole set of pairs. Do you see any guy, any X listed more than one time with therefore having more than one girl? No, you don't. And so we're good. And same with our last example. In that last example, girl 5 is dating all 4 of the guys. Guy -1, guy 0, guy 1, and guy 2. But you know what? If I input a -1, what do I get out? 5. Definite answer. Input 0, what do I get out? 5. Definite answer. Input 1, what do I get out? 5. Definite answer. Again, I have a definite output for any given input. All right, so here are some examples that are not functions. So the first one is because we don't have pairs, right? 7 is all by themselves. I don't even know if it's a guy or a girl. Hard to tell, all right? Because they're not paired up. So there's no pair. And because everything's not paired, you say, but 1's paired up with 3. Keep losing my comma there. 2 is paired up with -1. Yeah, but 7's not paired up with anybody. Everything needs to be paired up, and therefore it is not a function. It's not even a relation. Number 2. All right, look at example 2. So -1 is dating 0, 2 is dating 4, 2 is dating 6. Uh-oh, we got a problem there. 2 is dating 4 and 6. So again, let's go back to our input-output, because again, this is what's going on. If I input -1, I definitely get a definite output of 0. But if I input 2, what do I give you out? I don't know. I don't know what to give you. Should I give you the 4? Should I give you the 6? I don't know. And you lock up. Your computer locks up. I don't know what to do. There's more than one possibility, and how am I to decide? I'm just a machine. And that's really what's going on. I don't have a definite output for you. I don't know whether to give you the 4 or the 6. Therefore, it's not a function. Higher up in math, we'll figure out ways of getting around situations like that with restricted domains and such, but that's a whole nother story for a whole nother day. All right, example 3. Not only is guy -1 dating 2 girls, but guy 0 is also dating 2 girls. Don't ask me how guy 0 got 2 girls. He's just a 0, but you know what? Beauty's in the eye of the beholder, isn't it? All right. D. Functions and relations can be represented 4 ways, perhaps even more. We're going to talk about 4 ways. All right, so let's just list them here. How about written as an XY chart? Written as an XY chart. Number 2, set builder notation. You had that in geometry. I'll review it with you in a minute. 3, graphically. Graphically. And then illustrate with a mapping diagram. So 4 ways to represent a function. Let's take a look at these right here. Let me get rid of my shade. All right, so an XY chart. So right here, if you'll focus your attention on the example, here's our example function. F of x equals 3x plus 1 given the domain. Oh, we're told the domain. So here would be an XY chart. I know -2 is part of my domain. 0 is part of my domain, 1 is part of my domain, and 2 is part of my domain. And I'll use the function to figure out what girl each guy is dating. So first off, I'll do guy -2. What do? You simply put in -2 into the function where the x is, right? Remember this? Pretty simplistic. So 3 times -2 is -6. -6 is 1 is -5. And so write that in green there. Guy -2 is dating girl -5. Yes, a match made in heaven. And you're going to just follow this format all the way through. I'm going to do all my f-ofs here and get all set with my color. 0 in that one, 1 in that one, 2 in that one. Again, each time you're going to input into your function. So again, pause the video if you need to catch up. But you can see I'm just trying to do everything at once and use my color here. So again, 0 is going to go in for the x, 1 is going to go in for the x, and 2 is going to go in for the x. So if we look at the second one, right? 3 times 0 is 0. 0 plus 1 is 1. Look at the third one. 3 times 1 is 1, and 1 is 4. And the last one is 7. And now we've got an XY chart of our function. Set builder notation. Set builder notation. So if you remember how to say this, this is the set of all x, f of x pairs. Sometimes where f of x is will be y, all xy pairs. The one is functional notation, the other is just normal coordinate notation. It can be either way. So this is a set of all x, f of x pairs such that, remember your line is such that, that's ugly, such that, all right, such that f of x equals, and now we need the rule here, 3x plus 1. Where did I get that from? I got it from our example, right? That's what we're doing. The 4 ways of doing this example. I need a semicolon, and I need to list my domain, where d equals -2, 0, 1, 2, and I need to close with a brace. Set builder notation. The set of all x, f of x pairs such that f of x equals 3x plus 1, and the domain is -2, 0, 1, 2. All right, number 3 is graphically. Well, all of these are points, so we're simply going to put a point on our Cartesian plane. So -2, -5, -2, -5 would be right down there, won't he? Right? 0, 1, right there. 1, 4, right there. And 2, 7, what do you do? 5, 6, 7, 2, 7 is going to be about up there, right? And that is the graph of our function. Hey, if any given test or quiz, I give you a Cartesian plane and you don't have enough space, just do it outside the plane like I did in that example. All right, and then the last is a mapping. Again, remember, one is the domain, the other is the range. What's the domain? -2, 0, 1, 2. List the range, -5, 1, 4, 7, and map them. Map them. Now it's really easy to tell if it's a function from a mapping diagram because you'll only have one arrow coming out of any given domain. If 2 arrows come out, then it's not a function. Let me show you what I mean. Let me go back to the first page here and look at this example. Again, you have only one arrow coming out of anyone. So therefore, this is a function. All right. Okay, so those are the 4 ways that you can display functions, represent functions. And again, we're just getting rolling here, so this is pretty simplistic stuff. They want us to graph f of x equals 4x minus 3 for a domain of -1, 0, and 2. So sometimes they'll show that in set notation. Other times they'll just list them. I'm trying to show you all the possibilities. It's just an XY chart. Again, this is pretty boring stuff because this is Algebra 2 and we've done all this stuff already. So -1, 0, 2. And again, remember, you're simply plugging in to the value of the variable. So I'm setting them all up at first, right? Because one time I got to put a -1 in for the x, and then I got to put in 0 for the x, and then I got to put in 2 for the x. And so we end up with what? -4 minus 3 is a -7, and this is a -3, and this is a 5. You're just plotting the points. -1, -7. Up there I am off the charts again. Great. -1, -5, -6, -8. I don't know. Probably down there. Here, I'll put a line for 7 there. -7, right? 0, -3 is right there. And 2, 5 is right there. And they're just points. No line between them because we're just given specific values of the domain. So that's all that function contains. Guy -1 is dating girl -7. Guy 0 is dating girl -3. And guy 2 is dating girl 5, right? And that's the way that goes. All right, last example here. In this one, we've got set builder notation, graph all the xy pairs such that y equals 5x plus 1. Here's our function right here. All right, 5/2 x, I'm sorry, 5/2 x plus 1. But then it gives -2 less than x less than or equal to 2. All right, we should remember this. We should remember this from doing conjunctions, right? This is a conjunction notation. So you have to understand already what this means. Remember what it means. It means we have values just larger than -2 because again, look, there's no equal to. If there would have been an equal to, -2 would be included. So we're just larger than -2 all the way up to, because it's the equal to part, +2. So our domain has values just before -2 all the way up to 2. All right, so how are we going to do this XY chart? XY chart. Now I am going to use -2 as part of my domain. I'll show you how we'll do that in a minute. So -2, -1, 0, 1, and 2. I don't really even need all those points. I really just need the 2, but you'll see that in a minute. Okay, let's go ahead and do our function each time. All right, let's see. For time's sake, I'm going to skip -1 and 1. We don't need them. Let's go 5/2 for the 0, and let's go 5/2 for the 2. Now, you might say, well, Mr. Scarfi, how would I know I don't need them? Because we're doing linear functions right now, and we should be able to recognize a linear function, and linear things are in a straight line. And so any 3 points will give you that straight line. Technically, any 2. But if you remember, we always do 3 because what if you make a mistake? You know you made a mistake in one of the points because it doesn't line up well. All right, so again, we're going to put -2 in on the first function. So let's arbum, reduce before we multiply. -2 divided by 2 is a -1. -1 times 5 is a -5. -5 and 1 is a -4. So we get the point -2, -4. 0 is always handy. 5/2 times 0 is 0. 0 plus 1 is 1. And then 2, again, reduce before you multiply. And you get what? 6. Excuse me. Okay, so now we're ready to graph this. I'm going to use my red here. So take a look back at your XY chart, looking right here. The point -2, -4. However, look back at our domain. Is -2 part of the domain? No. Value's just bigger. So I need a circle around the -2, -4. So -2, -4, I do a circle. Right? Remember, that means that number is not included. All right, let's go up to 0. We have the point 0, 1. I'll put a point there. And we go up to 2. And we have the point 2, 6. And we put a dot there. And here's the thing. We need all the values in between. So we now connect everything up. Okay? Not the straightest of lines, but you get the idea. And now we have illustrated all the values of this function. So all the different pairs, and there's an infinite set of pairs in there. Any value just bigger than -2 all the way up to 2. All right, that's it. Remember, no homework tonight. You'll be doing it in class tomorrow. All right, have a great night, and we'll see you tomorrow.